So we saw with optimization problems that we had to always have another equation because we didn't know how to take the derivative, right? There were too many variables in there, right? Correct? Well, here, we still only have two variables, right? We only want two variables, but we're not solving for y. Here we have x squared plus y squared equals 25, and we want to be able to take the derivative without me having to solve for y, because that's what we've been doing so far, right? We take the derivative, we'll always have y equals, and then we take the derivative. Well, I don't want to have to be able to do that. So I want to be able to use implicit differentiation, okay? So here it's defined implicitly as it is not solved for any variable. In the second example here, y equals plus or minus square root of 25 minus x squared, it's defined explicitly as it is solved for y. Okay? Still only two variables. Okay? We already know how to differentiate y equals plus or minus 25 minus x squared explicitly. We would change that root to an exponent of a half, and you would go ahead and use a chain rule. Right? We know how to do that. So let's talk about how to do this now. So I have x squared plus y squared equals 25. So what we're going to do is we're going to use a chain rule, okay, to do this. So I have here the derivative of x squared is just 2x. Nothing crazy there. And then we're going to take the derivative now of y squared. So what we're going to do is take the derivative, which is 2y, and then we're going to multiply by dy dx. And then equals 0. So what's the difference here? When I take the derivative of x squared, it's just 2x. But now when I'm taking the derivative of y squared, I take the derivative 2y, so now I have to multiply by dy dx, which is the same thing as, what's another way to write dy dx? Y prime. Yes? And that's probably what you're going to use mostly, rather than dy dx, is y prime. Okay? And then from here, we just solve for dy dx. Oops. And now solve for dy dx. So here I would have 2y times dy dx equals negative 2x. We're dividing now by 2y, and you notice that you get negative x. And this is your slope function. So why did I say it's a chain rule? Because you're taking the derivative, yes, with respect to y, and then we're multiplying by the derivative of y, right? Just like we would do with the chain rule. With a regular chain rule, if I had this, I bring down the 2, I leave this the same, this goes down by 1 degree, and then I take the derivative of the inside. Well, that's what I'm doing here. I'm taking the derivative of y squared, which is 2y, and then I'm multiplying by the derivative of y. Okay? Can anyone explain why I need to do that? Why would I need to do that? Because normally when I take a derivative, it's in the form y equals this whole thing. So if I were to take y prime, it's the derivative of this whole thing. And so now I'm including that in my equation. I'm taking the derivative of just your y. Okay, your y prime. Yes? Yeah, it's just like your chain rule. So what I want you guys to think of, when I do this, when I take the derivative here, I don't just write y equals and then take the derivative. That y changes to a y prime. Yes? And the reason that it's one y prime is because it's just one y. So it's y prime. Well, now I don't just have one y. Now I have y squared. So I take the derivative of that expression, but I have to multiply it by y prime. It's a chain rule. Yes. Cool? So let's try to differentiate some harder ones. What rule do I need to use here? What rule do I need to use here? I have x cubed times y plus x times y squared equals 2. What rule do I need to use here? No, you can, but you don't have to. Yes, you're going to use the product rule. It's a product rule. And the reason this is a product rule is because I have x cubed multiplied by y, and then I have x multiplied by y squared. Okay? So using our product rule, it's the first times the derivative of the second. You can either write y prime, or you can write dy dx. Both are correct. Okay, so for this example, I'm going to write dy dx. Okay, because the derivative of y is y prime. We know this. Okay, so the first times derivative of the second plus the second times the derivative of the first. And now we have a product rule again. So the first times the derivative of the second. We just saw that y squared is 2y multiplied by dy dx plus the second times derivative of the first. That's implicit differentiation. And now I want to collect my like terms and simplify for dy dx. Do you see any like terms here? So here, let's clean it up.
Miss,
Yeah,
why is it equals 0 on the first line?
because the derivative of 8 is 0.
Oh, okay.
Yeah, yeah, derivative of 8 is 0. Okay, so what can I do from here? I need to solve for dy dx. Did I lose a dy dx somewhere? Yes, I did. Right here. Okay, how would I solve for dy dx, guys? What should I do? I need these two terms together on one side, yes? Bring everything else over to the other side. I'm solving for dy dx. I didn't have any like terms, I couldn't bring anything together. So I leave my dy dx on this side, and I bring everything else to the other side. Okay, what would I do next? How do I solve for dy dx?
Factor it out and divide.
Excellent. We're going to factor it out. So if I factor out dy dx, I'm left with x cubed plus 2xy. And now I just have to divide that out. And you're done.
Did you miss the square, or what happened
Perhaps I did. Where did I miss a square?
with the negative y?
Yes, I did. Thank you.
And then the one above that too.
Thank you. And that's your slope function. So now if you wanted to know the slope, guys, you'd have to sub in an x and a y. Right? Find the slope. You're going to sub in an x and a y. Or alternatively, you could just sub in for y. You know that y equals your function, but that would be a lot of work, wouldn't it? Right? If you had to sub in your function. You guys following me? If I wanted to find the slope here, I have two variables. Well, that's just a point, right? So if I want to know the slope at a point, you're going to sub in that point, x and y. And what I'm saying is, alternatively, to get rid of y, you could solve for y and sub it in, but that's a lot of work. You don't want to be doing that, right?
Yes.
Yeah.
How do you know where to put the dy over dx?
What do you mean, how do you know where to put it?
Because you.
Yeah.
Yeah, because I just don't understand like why you put it next to the x cubed and then the other x.
Okay, ready? So when you're taking the derivative of y, what's the derivative of y?
1.
Okay, one, just one? So when you do your derivative, if I had y equals 2x plus 1, and I go ahead and I take the derivative of this, what does it equal? What would you write exactly as the derivative?
Then I would write 2,
What about on the left?
0, like plus 0.
Okay, 2. What about on the left? What does y become? Y prime.
Y prime, right?
Okay, so now what I'm saying is, if I have this, so now it's not just y. So I can't just write y prime. I have to take the derivative first. So the derivative is 2, and now multiplied by dy dx, or y prime. You see that?
Hmm.
So really, you've been doing this all along, but it's always been just y. So it's simple. Okay, so the derivative of y is y prime, not just 1. You guys see that?
So instead of dy over dx, is it okay if we just put y prime?
Yes, and you're going to see me do that as well. Okay, I'm going to
Okay.
choose both. Okay, for the next example, I'll use y prime. It is easier to use y prime.
Miss, I'm here.
Yeah? Oh, who's here? Who is that? I mean?
Jason.
What was it? Jason. Okay, let me fix the attendance. I'll fix the attendance in a few minutes. Just remind me, okay?
Okay.
Okay, thank you. Yes, I have a question.
Could you write like zero equals to x or two or y prime and then plus y?
Because it's the first function times the derivative, it's the second function times the derivative of the first function. It's your product rule. It's the formula. It's the formula for your product rule. So here's one product rule, and here's the other. It's two product rules. Cool? Okay, let's try another example. So let's look at this. So before I do anything here, I'm going to change its form. So 2xy squared minus, what am I going to do here?
Exponent.
Yeah. Good. Excellent. And then, if you wanted to, you can go one step further and bring that 1/2 into both. Yes? So you can simplify it first, just to make your life easier. Still going to be a product rule. Yes, we actually have two product rules again. So, first product rule. The first times the derivative of the second. So ready? What's the derivative of y squared? 2y, y prime, or dy dx. Yeah, same thing. Plus your second function times the derivative of the first, which in this case is just 2. Okay, now we have a product rule again. So it's my first function times the derivative of the second, plus the second function times the derivative of the first, which is 1/2 y to the negative 1/2 y prime. Is everyone following me? So you take the derivative just like you would as if it were x, and then you multiply by y prime. Okay, it's a chain rule. All right, so cleaning this up, I have 4xy y prime plus 2y squared minus y to the 1/2 minus 1/2 x. I'm going to leave this negative for now. I'll change it after. And now I need to solve for y prime. So look for the terms that have y prime in them. This one and this one. And that's what's going to stay on the left. Everything else moves to the right. So 15 minus 2y squared plus root y. Now I factor out that y prime. And now we divide. Is this form good?
No.
No. Why is it bad? This is not good form. You would not get full marks for this. Why?
Too many denominators.
Yep, you got it. I've got an extra denominator here. Let me highlight it. Because of this. I've got a fraction within a fraction. You can't have that. So how do I fix this? How do I fix this?
Common denominator, then multiply into each other.
Excellent. We're going to find the common denominator in this denominator. Okay, so the common denominator would be 2 root y. Yes, so the numerator stays the same. And in this denominator now, it's going to be 4xy multiplied by 2 root y. So it's going to be 8xy root y. And then minus x. And this is all over 2 root y. So we know that when we are dividing fractions, we multiply by the reciprocal. So when I'm multiplying here, I'm going to be multiplying by 2 root y all over 8xy root y minus x. So where is that 2 root y going to end up? Again, I should know that one?
The top.
Or Lily, I should say, sorry. Yes, in the numerator. And not your time. Any questions so far?
Miss.
Yeah.
So why are we solving for y prime instead of something like x prime?
What's the derivative? Whenever we have a function, we always solve, like if I have y equals 3x squared minus 4, I always want it as y prime equals, don't I?
Oh, okay. Yeah.
Yeah,
All right. Thank you.
no problem. So basically what we're doing here is we're solving in the end for y prime rather than solving for y at the beginning. So instead of solving for y at the beginning and taking the derivative, we take the derivative as it is, and then we solve for the y prime in the end. Okay? Yes. You leave it out. Yes, remember we always teach in factor form. You should leave it out. Okay? Good. Okay, next example. All right, so I have x minus y all cubed minus equals 3x squared. So I don't want to solve for y. I don't want to expand this and solve for y. We're going to do it implicitly. And so the 3 comes down, x minus y squared. And now I have to multiply by the derivative of the inside. Derivative of x is 1. But the derivative of negative y is negative y prime. Do I see that? And then on this side, I have equals 6. Okay, I need to solve for y prime. So what do I need to do if I need to get y prime by itself?
Divide by 3x minus y all squared.
And you notice that 6 divided by 3 is 2. And now I have negative y prime equals 2x over x minus y all squared, right? 6 divided by 3 is 2. And now I'm going to subtract 1.
This comes to, y minus instead of y,
Where?
different, y minus x cubed y.
Yes, so the derivative of y is y prime. Yeah, you see that? So the derivative of x is 1. The derivative of that y is y prime. Okay? And now from here, I can't leave negative y prime. So it's going to be y prime equals, and I'll just flip this because we know the signs change. Now, can I leave it like this? What do you guys think? What's the rule? To be fully simplified, what do we need? We need one
Same
denominator.
denominator.
Yeah, we need this all together. And so we're going to find the common denominator, which is x minus y all squared. And that's your final. Any questions so far? Okay. So find the equation of the tangent to 3x plus 5y plus 2xy squared equals 15 at 1 comma negative 4. So find the equation of the tangent. In order for us to find the equation of the tangent, what do we need? Yeah, we need the slope, yes? And to find the slope, we know that that's the first derivative, then sub in your value, right? Sub in your x value. All right, so we're going to find the derivative here. So I'm not going to solve for y, I'm going to do it implicitly. So the derivative of 3x is 3. What is the derivative of 5y? Excellent. 5y prime. Now, I have a product rule. The first times the derivative of the second, 2y, y prime, plus the second times derivative of the first, and then the derivative of 15 is 0. I want you guys to take it from here, okay? Work on this for a couple minutes, and we'll take it up. And please express the equation in standard form. Okay? Equation in standard form. And I will be right back.
Miss, are you gonna change my attendance?
I'm sorry?
Are you gonna fix my attendance?
Oh, yes, thank you. CJ said thank you for reminding me. I'll do it right now. Did
Thanks.
anyone else come in? Did Nigel come in?
Nigel's here. Yeah.
Nigel's here too. Hi, Nigel. So Nigel's here, Jason is here, and what about Amin? Did Amin show up? No, not Amin. Okay. Okay, so I'm gonna mute this because I know you guys get static, and I'll unmute when we're gonna pick it up, okay? Yeah. We're still gonna talk about equating the lines and slopes and stuff, but maybe it's totally different right now. Some people do find it easier, some people don't. They all find that if you love physics, you're good at physics, and you love that. If you love algebra, then you love calculus. Okay. Some people like both, right? Some people do all of both. Okay, now I need to solve for y prime. So we can clean this up if it makes it easier for you guys.
Miss, you're not sharing your screen.
Uh-oh. Thank you. Okay. So now from here, we want to keep whatever has a y prime, because we need to solve for y prime, and we're going to bring everything else to the other side. Cool? Now we're going to factor out that y prime. And then we're going to divide. Remember, guys, this is your slope function. Okay, now from here, I need to find the slope. In order for me to get an equation of a line, I need a slope. So I'm going to sub in the point that they gave me. And they gave me x and y, so I don't need to solve for anything. 1, -4. So we're going to sub that. And what did you guys get when you did this? Sorry? That's careful. It is over 11, yes, but I don't think it's 29. What is it?
35.
35. 35. Good. So, from here I've got the slope, and now we use our point slope. You guys might use that y equals mx plus b, but I do encourage you to try using this equation. Okay, it's a good equation. It's basically just your slope rearranged, right? Okay, so y plus 4 equals 35 over 11 times x minus 1. From here, you can multiply everything by 11. Okay, I expanded there on the right, and now we can put it.
This is going to be 44.
Oh, sorry, I meant to write 44. Thank you. So 35x, where was I? Minus 11y, minus 79 equals 0. Guys, notice, no decimals, no fractions, the a value is positive. That's your final answer. Okay? Good? Yeah.
You have 5y. You're able to do 5.
Y prime. Or 5 dy. Both are correct. Okay, this is your homework, guys. What I would like you to do right now, read section 5.1, do this homework. The photocopiers were not working yesterday, and for some reason my file, when I'm trying to open 5.1, it's not opening. So I'm going to try to fix that problem, and I'll be right back. Okay, so for now, just start this homework, and let's see what I can do.